Welcome back to Business Literacy Numeracy, working with numbers, and we are now in part 4, Miscellaneous Calculations. And in this video, I'm going to show you how to do a couple of the miscellaneous calculations that often comes up in the ICB's tests and exams. First one we are going to look at is finding a missing number in a table. And there's a simple rule here. It says solve rows and columns with one missing number first, and there's two ways to do that. You can add numbers to find a missing total, or you can subtract all the numbers in a row or column from a total to find a missing number in that row or column. So in the table that we have here, we have 4 sales representatives, and with their commission figures for January, February, and March, and then the total for the entire quarter, and then also the total for the different months if you add the reps commission together. But there's missing information, and now we have to complete the table. So if we start here and we look at January, we cannot complete anything here in the January column because there are 2 missing figures. The same here for February, but when we get to March, we can see that there is only 1 missing figure, so we would be able to calculate this figure for March. Once again, here in the totals, if we're only looking at the columns, then there are 2 missing numbers. If we look at the rows, now remember that one would be possible. If we look at the rows, we cannot complete row 1. We can do row 2. We cannot complete row 3, but once again, we can complete row 4. Okay, so let's start somewhere. I'm going to start right here in this row for Vilakazi, and I see if I want to calculate his commission figures for January, I will have to say 14,115 minus 4,740 minus 4,185, and that'll give me an amount there of 5,190 Rand. Here, let's go to this column where there was only 1 missing figure. So for March, the total is 20,115 Rand. And if we now want to calculate the commission figures for Kutsia for March, we will say 20,115 minus 441 minus 4740 minus 53,110, and that'll give us an amount of 5,624. Now that we have done that, things become a lot easier. We can now simply add these numbers together to get the total for January, and we can add these numbers together to get the total for Kutsia. Now we can really work in any order because now wherever we look, there's only 1 number missing in a column, except here. So we will either have to do that one and that one before we can do this one. However we do it, this February figure for Jakes will be the last number that we will be able to record, unless of course we find one of the others false, then we might as well do that. So okay, let's have a look here. If we want the total for Jakes, we will subtract all these numbers from the 5817, and we get 13,816. Now we can subtract the 5,310 and the 3,825 from that 13,816, and we get 4,681. And now we can subtract all of these numbers from the total that we have for February, and then we will have Msimang's February figures, and that's 4,694. The next one is the calculation of averages. Now remember that the average is the sum of a set of numbers divided by the actual number of numbers in that set. And I've given you an expression there, A equals Sn divided by n, where sum means add. But let us have a look at the example, then you will understand it a lot better. Here's the example. You write 3 tests of equal weight and get the following marks. You get 55%, 60%, and 80%. And you now want to know what is the average for these three tests. So what do? You add the marks and you get to 195%. Just remember to keep this percentage sign. I'm going to say it here at the end as well. And then you divide the total with the number of tests. How many tests did you write? 1, 2, 3. So we say 195% divided by 3, and then we get the average there of 65%. And as I already said, just remember to keep the unit that you started with. If you started with percentages, then you will stick with percentages. Sometimes in the exam, they will ask you an average, but then they will express some of the figures in meters, for instance, and some in kilometers, and then you have to first work back to 1 unit, and once you are working in 1 unit, only then will you be able to calculate the average. Next one here is a power. So what is a power? A number multiplied by itself any number of times can be written as that number to the power of the times it is multiplied by itself. So example, we have 5 times 5. That means that 5 is multiplied by itself 2 times. So instead of writing 5 times 5, like I did there, we can simply say 5 square, and that will give us 25. Of course, if we add another times 5, it becomes 5 times 5 times 5 times 5. And then, of course, we can still write that as 5 to the power 3. And 5 to the power 3 will then be 125. On your calculator, this is often a y to the x or the x to the y, or the little exponent sign. You need to understand how your calculator works, because you're going to have to apply these later on, especially when you do the interest calculations, and then you know how to need your own calculator. A number to the power of 2 is known as a square. So 5 to the power of 2 can just be said it's 5 square. And any number to the power of 1 will always be that number. So 5 to the power of 1 is 5. A million to the power of 1 is a million. But any number to the power of 0 will be 1. Okay, so 5 to the power of 0 is 1. 18 to the power of 0 is 1. Whatever the number is, if it is to the power of 0, it is 1. And that is because we're working in the decimal system. Therefore, anything to the power of 0 in the decimal system will be 1. What about roots? A root is the opposite or the inverse of a power. So if n square is x, then the root of x will be n. Okay, let me show you some examples. We go back to our 5 square example. 5 square equals 25, and the square root of 25 is 5. 5 times 5 times 5, as we saw on the previous slide, is 125, and the cube root of 125 is 5. Then we have 5 times 5 times 5 times 5. Now there are 5 5s multiplied, or 4 5s rather, multiplied by itself, and we can write that 625, and so therefore the root to the 4th power of 625 will be 5. And so we can go on. There I've done it to the power of 5, and you can continue. The idea really is that these two are the inverse of each other. Okay. Order of operations, the root, now I'm saying it to you, the root and the equivalent power of a number will cancel each other's out. So if here in the bracket you have the square root of 8 that is squared, you will simply end up with 8. Okay, because there you have a square root and there you have a square. And if you were using the cube root of 8 to the power 3 will still only be 8. The square root of x to the power 2 will be x, and the cube root of x to the power 3 will also be x. So see that if your root and your power value is of the same order, then you will just be left with your constant. If a negative number is squared, the answer will be positive. Why? Because we saw earlier that a minus multiplied by a minus is positive. So 5 square is 25, but minus 5 square is also 25. Same here. 6 square would be 36, but minus 6 square would also be 36. And because you will always get a positive number when you're multiplying two negative numbers with itself, it is impossible to find the square root of a negative number. If you take a negative number and you put it into your calculator and you ask for the square root, you will get an error message. And those are the miscellaneous calculations that you must be ready to complete in your ICB tests and exams. Thank you.